So one of the most controversial things about JavaScript is its type system. JavaScript chose to trade type safety for dynamism. A lot of people wouldn't make that trade-off, but that's the trade-off that they made. So JavaScript has no cast operator, which is a good thing. Reflection is really easy in this language because you can always look at an object and ask, what are you about? You know, do you have this method? Do you have this value? So reflection is easy in this language. So you step back and you ask, well, why do we have inheritance at all? Why is inheritance important? I contend that we get two things from inheritance. One of them is automatic casting, because a type system in which you have to explicitly cast things, I contend, doesn't really give you any type safety. So automatic casting is important. But in JavaScript, we never cast. An object reference is always an object reference. So that doesn't get us anything. The other reason we want inheritance is for code reuse. And as we've seen and as we will see, JavaScript provides many, many patterns for code reuse that we don't need classical inheritance in order to accomplish those. So ultimately what JavaScript does is trade brittleness for flexibility. Is it a trade-off? Is it the right trade-off? I don't know, but that's the state of the language, so that's what we have to work with. I found over the years of working with JavaScript, I used to be of the religion that said, yeah, absolutely brutally strong type systems, figured it all out at compile time. I have now been converted to the other camp. I found that the expressive power in JavaScript is so great. I have not felt that I've lost anything in giving up the early protection, particularly since I wrote my own tools to make sure that I get some reliability anyway. We'll talk about that again later. For completeness, JavaScript has a date object. It was based on Java's date class, so as a result, it was not Y2K ready. It was only 1995. I guess they didn't see it coming, but they have since fixed it. JavaScript has regular expressions. It copies some of the Perl conventions. Regular expression literals are enclosed in slashes, which is a little problem syntactically since slashes already mean comments and division. So you have to be careful about where regular expressions can go. This is a regular expression which matches regular expressions. At least that's what I claim it is. There's really no way you can tell looking at it what it actually accepts and what it rejects. Regular expressions are a bizarre notation. I think they're really difficult to read. It frightens me that we rely on them so much for validation and for securing our systems when we have really no idea what this is doing. Doesn't seem to me the basis of any kind of system of security, but they're really popular, and so JavaScript's got them. And I use them a lot, but I recommend be really, really careful with them because it's really easy to get them wrong and you don't get much indication that you did. Threads are a way of doing concurrency. The JavaScript specification is neutral on threads, doesn't say it has them or doesn't have them. There are some language processors like the SpiderMonkey JavaScript engine, which does provide thread support. Most application environments, such as browsers, do not provide thread support. All of the browsers at the application level are single-threaded, which is really good because threads are evil. It's really hard to think well about threads. They don't belong at the application level, so it's just as well that we don't have them. JavaScript is provided on lots of platforms now. It's obviously in all of the browsers. It's also finding its way into operating systems now in Windows Script Host and in Dashboard on the Macintosh. It's in Yahoo Widgets, formerly known as Confabulator. It's got a JavaScript engine built into it. It's finding itself in desktop applications. Dreamweaver and Photoshop have JavaScript built in. PDF has JavaScript built into it now. It can be embedded now into virtually any application. So the time that you invest in learning JavaScript, it's going to be helpful in doing web development, but it's useful in a whole lot of other environments too. So I think it's definitely worth the trouble to learn it. A JavaScript-like language is ActionScript, which is found in Flash. This is a list of differences for ActionScript 2. A lot of the Flash community contends that ActionScript is an ECMAScript language. It's not compatible. Programs written for one will probably not work in the other. There is a newer language called ActionScript 3, which is in the current Flash, is also not compatible with JavaScript. And that's a problem for Adobe. They'd really like Flash to be based on a standard programming language. And the way they got to ActionScript 3 was there was a proposal for an ECMAScript 2 that was developed by Microsoft and Mozilla, or Netscape, I guess, at the time. But they couldn't agree on the details, and at some point they so enraged the ECMA committee that they didn't want any part of it, and so it never became a standard. Not knowing how it was going to turn out, Macromedia went ahead and implemented it anyway. And so they tried to get in front of the standard and instead unstandarded themselves again. One thing that did become a standard was E4X, the extensions to ECMAScript for XML. This is something that was proposed by BEA, and it provides for XML literals in the language. So any place you can have angle bracket things and write out expressions. It uses the @ sign for getting at attributes inside of XML expressions, sort of XPath type expressions inside of JavaScript. It's implemented in Firefox, but not most other places. And in particular, Microsoft has not implemented it. It's not in IE 7. Who knows if it's going to be in IE 8 in a year and a half. You know, as I always say, 9% is not enough. And the big problem with this is it's all syntax errors for the old JavaScript. So if you load JavaScript with the E4X features, you get a syntax error, the program doesn't run. If you get a syntax error, we don't get paid. So you can't if around this stuff because the compiler rejects it and it all goes out. So my advice is don't use E4X as much as you might like an alternative to the DOM interface, which is really horrendous. For most applications, this is not an alternative, which is too bad. Now, Microsoft had 3 people on the committee that standardized this. All 3 voted yes. So Microsoft cast 3 yes votes for the standard and then chose not to implement. So that one's DOA, or so it appears. Now there's some new activity going on, a 4th edition of ECMAScript. The 3rd edition was published in December of 1999. So the language has been sitting still for quite a long time. And so in that time, they've decided to take another attempt at creating a new standard based on it. A very large set of new features are being considered, including type declarations, classes, yields, deconstruction, a whole lot of stuff. Some of it is likely to be very popular, particularly for the people who don't want to have to learn to think differently. It might be possible to use this language that way. It's going to have an object model which is more Java-like. But at the same time, it's going to have to be compatible with the old model. And it's not clear if those 2 worlds are going to play where it can be completely loosely typed and strongly typed at the same time. One thing we do know is it's going to turn from a small language to a large language. I'm not sure this is necessarily a good thing. Mozilla is pushing this. Adobe is also pushing it very, very hard. Adobe wants it to be a standard. Microsoft is really not paying attention to it. So it's not clear if they're going to adopt this one either. And no word from Safari yet. They haven't paid any attention. But I'm guessing if Microsoft goes along, Safari will have to. But we don't know what Microsoft's going to do. Let's talk now about style. Programming style isn't about personal taste. It's about rigor in expression, about clearness in presentation. It's about product adaptability and longevity. Good rules help us to keep the quality of our programs high. Style is important in all programming and all programming languages, but particularly in JavaScript. Because the language is so soft, because it's loosely typed, because it has errors in its design and some other factors, it's really easy for a program to collapse into a puddle of confusion if you don't have really strict style rules working for you, since so little else about the language is strict. So I've discovered that most of the world's body of JavaScript programs is crap. I believe that's
90% of everything.
well, it's particularly true of JavaScript. And it doesn't need to be. I believe it is possible to write really good programs in JavaScript, but it does require attention to style. So we're going to look at some code conventions that I've developed specifically for JavaScript. You can read about them at javascript.crockford.com/code.html. My ambition is to eventually turn these into Yahoo standards and have all of web development and all the JavaScript development at Yahoo conforming to these. I think it really will make us more productive and improve the quality of our code, which should ultimately make us all a lot happier as well. So these are some of the specific things I'm recommending. In JavaScript, when the compiler sees an error, it attempts to replace a nearby line feed with a semicolon and try again. This should freak you out. It can mask errors, so I recommend that you always use the full correct forms, including semicolons in all the right places. This was done intentionally in the language. This was an intentional error in order to make the language friendlier for beginners. Syntax is complicated. You don't know where all the semicolons are supposed to go. Don't worry about it. But JavaScript syntax is based on C, and C has semicolons for a reason. The grammar is ambiguous without semicolons. JavaScript has those ambiguities. It tried to resolve the ambiguities by aliasing line feeds into semicolons. So it replaced one ambiguity with another. Not generally a good idea. So be strict in your syntax. Because of semicolon insertion, you need to be particularly cautious with line breaking, because certain copy-paste errors are not detected by the JavaScript compiler. So I recommend that you always break a line after one of the punctuators, and that you not break a line after a name string or number or a closing operator or an increment operator. This will help detect certain errors easier or make them possible to detect. Avoid tricky expressions using the comma operator. And also don't use extra commas in array literals. This is the good way to write an array literal. This is the bad one. The difference is this one has a comma. Why is it bad? Because Netscape will tell you that the length of this is 3, and IE will tell you that the length is 4. And doing cross-browser stuff is hard enough without this kind of stuff getting in the way. I recommend that you always use blocks around structured statements. So this one is 2 characters more than that one, but this is provably a source of errors, particularly in large projects or ongoing projects or projects with lots of programmers on them. It's really easy for this one to get corrupted, whereas this one tends not to. So this resilience is well worth the 2 extra characters. Blocks don't have scope in JavaScript, so don't use blocks strictly for scope. So I recommend that blocks only be used in the structured statements and nowhere else. Define all of your variables at the beginning of the function. Since you have function scope rather than block scope, put them where you know they're going to be. In some languages, you like to define them as close to the site of first use as possible, and that makes a lot of sense in other languages. Unfortunately, it doesn't really make sense in this one. So some of the style rules I'm recommending are different from rules that you may have seen in other contexts, but that's because this language is different than other languages you may have worked with. JavaScript, like the C languages, has expression statements, but those can mask errors, particularly when you have semicolon insertion going on. So I recommend that the only expression statements be assignment expressions and invocation expressions. In no other case should you be using expressions as statements. So it's okay to call a function. I mean, you have to be able to do that. But using an AND operator here to control flow, I think is a bad thing. I would rather see this written as an if. Avoid fall through in switch statements. Every clause should explicitly break or return or throw. Do not use assignment expressions in the conditional parts of ifs and whiles. The reason is that this is more likely to mean that. And so if you're in the habit of writing this form, it's really difficult to determine when the mistake occurred. So it's much better to never do this. Be aware that double equal and not equal do type coercion. So this statement appears to do what this statement does, but actually does what this statement does. So a statement which appears to do one thing and does another can lead to errors. So I recommend figure out which of these you mean and write this one, whichever one it is. In some cases it means putting in an extra equal sign. I'm happy to pay one more character in that case. If you're just looking for a value which is falsy, then this form's actually smaller and faster, so you're better off with it. One place where I've seen this one used is they pull A out of an object, and they look to see if it's null. But the thing they were really looking for was undefined, but they were confused about the difference between null and undefined. So they actually had two errors that canceled each other out. That's a bad way to program. It's better not to be making so many errors. Only put labels on the statements that make sense with labels, so do, for, switch, and while. And never, ever use JavaScript : as a label. And also avoid as much as possible using JavaScript URLs. That, I think, was a bad idea in the browsers and something we should try to get away from. So JSLint is a program which will check for all of these things and will provide an automatic search for all of these and will help uncover errors in your program. Also give you a map of all the variable definitions in your program showing which are bound enclosures and which aren't, and give you a list of all of the field names that are used in your program. This can be extremely helpful in improving the quality of your programs and can also be helpful in debugging. JSLint does all of that. It can find things which are really hard to find in debugging. It provides a lot of the safety that we liked strong typing for. Even though we don't get strong typing in this language, having automatic detection of errors is really a helpful thing. JSLint is available as a web page, so you can just paste your program in it and it'll check it locally. It's also available now as a confabulator widget and can also be run in the desktop. It's getting built into text editors now. It's going into Eclipse. So again, I highly recommend that you be running all your programs through JSLint. One warning though, JSLint will hurt your feelings. Bad. It is a cruel, arbitrary program, but if you can stand it and listen to its advice, it will make your programs better. So to wrap up, these are what I think are the key ideas in JavaScript. Load and go delivery, in which programs are delivered as text. Loose typing, which takes some getting used to, but I think is a very powerful thing. Objects as general containers, which I think was brilliant. Prototypal inheritance, which turns out to be a pretty useful thing. I mean, it's why JavaScript is succeeding in the thing that Java was intended to do and failed at. Lambda, which is probably the best idea in the history of computer science, and linkage through global variables, which is probably the worst idea in the history of computer science. It's all there in one language. It's JavaScript. We'll continue next week with the theory of the DOM, and the week after with advanced JavaScript. I hope that you'll all come for those. I'll see you next week. Good night, everybody.